and welcome to Automation Alley's virtual Tech Takeover series hosted by SICK. I'm Allison Trumbull, Account Executive, and if you aren't familiar with Automation Alley, we are a World Economic Forum Advanced Manufacturing Hub, or AMHUB, and Industry 4.0 Knowledge Center. We host a plethora of events, such as this one this morning, to obtain content from every aspect of Industry 4.0 to give businesses a competitive advantage by helping them along every step of their digital transformation journey. Here we obsess over disruptive technologies like AI, Internet of Things, and automation. And our goal is to really work hard to make these complex concepts easier for companies to understand and implement. So before we begin, I'd like to remind all of our viewers that we do have our virtual Integrate conference coming up in November. It will run very similar to our previous in-person Integrate conferences. We'll have breakout sessions, expos, panels, keynotes, and we also will have roundtables. So at these roundtable discussions, it will help Automation Alley define our state's Industry 4.0 strategy and help us prioritize which technologies and topics to focus on throughout the year. So don't forget to register for Integrate at integrateconference.com. If you have any questions about participating on a roundtable, if you want to participate in an expo, speak, or attend, please reach out to me or go to our website, as well as if you have any questions about sponsoring or speaking. So today for our Tech Takeover, or our member-led Industry 4.0 focus session, the topic is real-time supply chain visibility through track and trace localization solutions. Today we have SICK joining us, and I'm pleased to be joined by a couple speakers. We're going to have Matt Kyle, their automotive sales manager, Jeff Konslick, the automotive parts supplier sales manager, Jeff Reamer, national account manager, and Tom Bonucci, manager of sales and marketing transport logistics. So today they're really going to dive in and showcase the solutions SICK Technologies provides with use cases, demonstrations, and this is going to be specifically for suppliers or end users of supply chain solutions that are looking for real-time visibility of assets, people, products, or shipping. So don't forget, we do have a Q&A at the bottom. We'll be answering questions at the very end. So if anything comes up throughout the presentation, please click that little box and ask all the questions you want. Stick around as well. This will be recorded and on our website. So without further ado, thank you to everyone from SICK today, and you guys can take it away.
Good morning. My name is Matt Kyle. I am the automotive sales manager for SICK in North America. And we're joined by a group of, well, not start my video later, sorry. Obviously, we're group, she already introduced everybody, but I just want to kind of go around the room. So Jeff Konslick, he is our automotive parts supplier sales manager. Mainly for parts suppliers, the main integrators like Magna, Forcia, things like that. Jeff Reamer, he's a national account manager focusing on the tire industry. And then Tom Bonucci, as we mentioned, he's the manager of sales and marketing for transport logistics. So we will get all the contact information when this is over, and you guys can send out any requests for meetings or discussions further. This is the agenda. I'm going to start out, kind of go through a just general introduction of SICK and really look at identifying what the real-time visibility is through this localization Industry 4.0 solutions that we've come up with. Jeff Konslick will then move over and talk about some of the trends and solutions in the part suppliers. Jeff Reamer will focus and talk about where the future's going in the tire industry with localization, some of the trends there. And then Tom Bonucci, he'll focus more on mobile platforms and how the transition's happening between standard conveyor to AGC to give us more flexibility in what we're doing there. And then we'll move on to Q&A. So we are SICK. It is not an acronym. So I know you'll see SICK and you'll see sensor intelligence. And what SICK is actually a name. It is Dr. Irwin SICK. He founded the company in 1946, so more than 70 years ago. Started in a small shed, as they say, where he sat down and tried to find a way to focus on safety and environmental protection within manufacturing facilities. And the main claim to fame at the beginning was we invented the first safety light curtain. So light curtains that actually protect workers, basically in stamping presses back when it started, using time-of-flight and light technology. We're headquartered in Waldkirch, Germany, and our mission is basically focused around independence and mainly innovation. You'll see that we have been kind of the pioneers and the innovators of a lot of the technologies that people have come to use on a daily basis when it comes to sensor technology, vision, LIDAR, and you'll see some of those things as we move through. We are a global company. We're one of the leading companies in this sector. We have 50 subsidiaries around the world. We're close to $2 billion in sales and more than 10,000 employees. So if you have solutions from a global standpoint, we are there to support you in any place in the world. Also family owned still. So to have a $2 billion company to be still family owned by the Sick family and a board is pretty flexible and amazing. So what's the sensor intelligence part? Why do we mention that, and why it's our core? So what we're doing is we're trying to take all these sensors that we've come up and innovated in the last 70 years, and with Industry 4.0 on the horizon and knowing we have to tie them into the internet, we have really focused on developing solutions that are smart. So we can create these smart factories, take all the data from these sensors, collect that, send that so we can make real-time decisions. We focus in a couple different main categories: detection through proximity type sensors, identification through barcode tracking, RFID. That's what we'll kind of focus on today. Protecting with safety, measuring distance sensors and LIDAR. And then finally, we get into controls and integration and different simulators where we can actually now put the entire system together in one package. So the big thing for us, as I think everyone's seeing, is that we have to take the sensors, we need to connect them from machines and equipment and send that data out. We need to make them easily programmable, and then we need to put them in some sort of ecosystem out so people can easily make decisions via cell phone, iPad, computer, whatever it may be. But that's the focus, is taking all of this sensor data and being able to make quick real-time decisions. So what is so fascinating about sensor intelligence? I think the thing is that it's so broad now that we started out with just safety, and then we moved into some track and trace solutions and sensors, but it is now moving across every aspect of every industry with automation, safety, creating efficiency improvements, tying into the Industry 4.0 resolution and the human-robot interaction, which last year that was kind of our focus, was the robotic platforms. We do have the broadest portfolio in the industry. A lot of our competitors focus on one of those sectors that I showed you with different technologies, but we have the broadest portfolio. So if you were to come to us, you would see that we have an all-in-one package for any of these different types of things, both in factory automation, logistics automation, and also out in the world of I can't even think of the word. Sorry about that. Good morning, everybody. Are you awake? I hope I am. All right. So everything that we do lately, they're very customized solutions for customers. There's small customers, there's large customers that are global. So we can create customized solutions and make them scalable. Working with larger automotive companies like a General Motors or a small mom and pop company locally. We're in every different industry. Obviously, this group is more focused on automotive, but airport, traffic, consumer goods, power, oil and gas, every industry out there, we are partnered with right now and helping them find solutions. So how can these companies benefit? We'll kind of go through a few kind of big examples that you guys have probably already seen. So we'll take you to the airport. Most people, not maybe these days, nobody's really going to the airports very often these days, but we have created a lot of the systems with the airports to track your luggage. So as you now see the Industry 4.0 on your phone, where it says your bag has left this terminal or it's at this place, those are our solutions with not only barcode reading, but lately with RFID that you'll see soon from the other groups. Robots, a lot of vision, a lot of safety there. And what we're doing right now is we're making them collaborative with people, with machines, and actually able to tie them into mobile platforms. The next one is with maritime and the ocean. We're doing a lot of measurement, reduction, emission problems. So again, focused very highly on the environmental solutions, and with a global economy being able to track and trace things from coast to coast. And then finally, what we're going to focus a little bit more on today is the Industry 4.0, the smart factory world. What we've done, not only through safety, but track and trace and vision and inspection, you will see that what we've done in our own factories, we can now present to the rest of the world. So what I'm going to do now is I'm going to show you a little video of our factory in Valkirk and show you how we practice what we preach.
Hey, Matt, your screen share stopped.
What's that?
Your screen share stopped.
Can you hear? Oh, it did?
Mm-hmm.
How long ago?
Just before you played the video.
Okay. Can you see it now?
No.
Okay.
There it is.
All right. Here we go.
Localization. How localization works in the world of SIG. Generation. Other conceivable applications are now in the planning stage. This is a flexible way of reacting to changing work processes. always with a focus on saving time and reducing costs through transparency. SICK uses a gateway system with GPS technology from its own portfolio for tracking company internal transport between different locations. In this way, we bring outdoor and indoor tracking together. In our own smart factory, we use either laser measurement technology or line guidance from our mobile platforms, depending on the requirements for positioning accuracy. Proven technology for automated guided vehicle systems. Localization is all about performance and accuracy. Our vision for the future is not fully automated production. Instead, it always includes a human, manual part of the work process. It will be about collaboration instead of competition, hand in hand, the best of both worlds. Transparency is therefore provided in both manual as well as fully automated processes. A guarantor for unreliably provided knowledge on the shop floor. In the distribution center, the material flow processes are managed with the help of localization solutions. In addition to the possibilities shown here of controlling industrial trucks, there are also possibilities of locating goods that have not been tagged. This is because SICK has one of the broadest possible sensor portfolios for localization. For example, LIDAR technology is used to locate and track entire transport units in an area. This is real added value. With LIDAR's help, absolutely all moving goods on the shop floor that are not currently being displayed in a track-guided process can be detected and reliably assigned. Localization by SICK means that nothing remains unseen, all with the aim of transporting the goods well, quickly, and safely to the customer. SICK goes further. Step by step, we are increasing our indoor localization capabilities and connecting them with the outside world. In this way, we are connecting the physical with the digital world and our own world with that of our customers.
All right, pretty cool. I wish I would have turned the sound on earlier, but let me share my PowerPoint now. Make sure there we go. All right. So what we're going to go through now is, you guys saw a ton of technology there, and there's no way in 15 minutes I'm going to be able to cover that. But I want to kind of introduce some of these technologies and make sure that everybody just has a general idea of what the different things are that we're going to focus on. So the first is really the ultra high frequency RFID. That's really been the game changer of moving to a long range RFID system so that we can track things in a great distance or within a major pallet. The next major focus is going to be on LIDAR. And what SICK did was, actually, because of safety scanner technology that we tried to create planes, we were one of the first to actually create LIDAR solutions that everyone's using now for autonomous vehicles. Also different vision systems and simple proximity laser switches. One of our newest solutions that everybody seems to be jumping on because of its capabilities is our ultra wideband solutions. So now we have the ability to take tags throughout an entire facility, or even phones. I know a lot of phones are coming out with ultra wideband capability, and we can tag base, localize assets, equipment, inventory, and even people. Some of the stuff that I was on a podcast or a webinar earlier this year about the new normal, and some of the things that we're doing with localization, where we're actually tracking, tracing people within facilities to understand if different areas have been cleaned, or different areas where people have been in contact. The other thing that we, throughout all this, is obviously we have to have a gateway to get these things to the cloud. So we'll talk a little bit about some of our GPS, our wireless technologies, all our different gateways, and IO-Link, linking all those things together, so easily programmable. Probably the biggest thing that, Industry 4.0 solutions don't really work unless you have software solutions. So we've developed a lot of new software solutions, packaging, analytics, different things like that, where we can track and trace and localize things. And Tom Benucci will kind of go through a few of those software solutions later. Another big part of SICK is, we're not just a commodity-based company. We are a service solution company. Half of our people here in the US and across the globe are actually full service people that come in and help with system design, installation, training, and integration and on-site support. So I'm going to leave it with that, and I'm going to hand it over to Jeff Konslik, where he's going to focus a little bit more on the automotive industry in the parts supplier, and tell you guys some of the trends and solutions coming there. Appreciate the time. Jeff?
Thanks, Matt. Good morning, everyone. Appreciate you taking the time to sit through our presentation. My name is Jeff Konslik. As Matt mentioned, I'm the automotive parts supplier manager. I've been in the factory automation controls industry for 30 plus years, the last 22 years with SICK, most of that focusing in on automotive. So I have some pretty good experience in that. So as Matt talked, and my screen's not moving. Okay. I'm going to stop sharing and try to share again. My screen seems to be locked up. Sorry about that.
Virtual tech takeovers.
Yeah,
there we go.
All righty, let's see if this is going to work, hopefully. So what Matt mentioned a lot, we do have a lot of different technologies. I'm going to focus basically on the RFID systems that we have. Back in the day, RFID was basically for pallet detection, just, 1, 2, 3, what pallet. We're getting into, you've heard the term asset tracking quite a bit. We're going to look at basically two different solutions, RTI and e-combine. These we see as trending applications that we're seeing a lot of visibility with our customers at the current time. For those of you who don't know what RTI is, it's basically parts in a crate that are leaving one station, A, to go to position B, and that can be in your facility, leaving to load it to a truck, and then that part being accepted at a major end user. Or vice versa. And then also you can just do, shelvings and things of that nature. Anything that would have a tag, we can track. So within our system, and I'll get into this a little bit more later, we can actually identify all the parts in the crate. We're not unlimited, but we do have a very high cycle, and it depends on the part size and things of that nature. But we're seeing this application come into play, and we'll jump into this a little bit more detail coming up. The second one I mentioned was e-combine. If you know what combine is, it's basically a feeder system for raw material in an assembly. Typically, they would have a card within each of these boxes or totes identifying what that part is. The problem is, as in the manufacturing process, you don't know when you run out of parts, and it's a visual accountability to see when that change has to be made, and then you have to make a call to someone into bringing more parts. In our system, it's all RFID. We follow the parts through the manufacturing process, so we know if the tote has 100 parts in, let's say, as we're taking parts out and those move along in the assembly process, we're tracking all that to you know, your EIP system, your cloud system, whatever. And as soon as we detect whatever that minimum level is, whether, you know, it's something that can be set, that signal gets fed, you know, to the right people so that we have just-in-time delivery of those raw materials, and that way it's, you know, more efficient. But again, we'll dive into that a little bit more as we move on. Just to give you an idea, this is I just wanted to touch base on the portfolio of what we do from identification solutions. You know, Matt mentioned we have barcode scanners and vision systems and handheld scanners, but I'm going to focus on the RFID. Basically, we have a whole portfolio of products that, you know, again, one of our strengths is we have such a broad portfolio of products that we don't have to just offer you one solution. We can cookie cut something, or we can totally custom design anything using any of these components depending on the application, you know, to meet your needs. So it's a really good strength of ours. We do have a lot of systems that go in that have long reading on the front end and short ones on the back end to just determine the different things. If you notice at the very top, we do have reading gates and reading tunnels. And again, we'll get into that a little bit more here. But basically, we cover the whole spectrum when it comes to RFID, and, you know, we can, you know, communicate just about any network that you need to. The reading gates, this is part of the RFID or RTI, which is just basically having a pallet. And again, it's not reading just the pallet, it can read the parts in the pallet. So we want to make sure that we're shipping the right part to the end user. Or again, if you want to count, if we're supposed to have 100 pieces and we only have 99, we'll be able to detect that and we'll be able to correct that shortage as we move forward. Tunnel is the same type thing. If you're in a conveyor type system where you're doing the same type process, our tunnel system basically does the same concept. It involves a little bit more product from a different end, but at the end of the day, it's basically the same solution. So we can do it, you know, whether we're driving a tow motor through or if we're working with conveyors. Just so people understand the process, I think this is a pretty interesting slide. You know, the parts supplier builds the parts, they pack the parts, they ship them on, they get labeled, and then they send them outbound. You know, all these stations here are points where we can be tracking RFID so that we make sure, again, we have the right parts, we have the right quantity of parts, it's going to the right place. And then as Matt showed in the video, once it gets transported, we can follow that as well. So we know that truck is going to the right plant, going to the right dock. You know, that helps from not losing packages. And then once the end user receives it, again, here's all these points that an RTI system could be used just through the whole process. So we can pretty much, you know, the terminology cradle to grave, we can pretty much follow the part from the beginning to the end to make sure that we have 100% accountability of, A, you're getting the right part, you know, you got the right number of parts, and it's very feasible for both the supplier and the end user. There's no, you know, hey, we got shorted, you didn't ship us the right thing. We have that visibility. So it's becoming a very hot trend for us. You know, it's one thing interesting, we're talking automotive here, so, you know, that's our expertise mostly, but this is not just for automotive. It can be for logistics, it can be for warehousing, anywhere where a part's going from, you know, point A to point B, you know, our systems can be used. And again, the fact that we can customize a solution to your requirements puts us just about any application that you can see fit that we can work with. So a big advantage for us. Just why, you know, we get back to RTI, what's the advantages? You know, I talked a little bit about this, but, you know, identifies and prevents losses. It's just in time delivery, and that's important. I think every part supplier and end user today is working on just in time. And, you know, if a part doesn't get delivered when it's supposed to, that causes a lot of headaches for a lot of different people. As I mentioned, we have consistent visibility of the flow of the process. So it's just not, here's your parts, good luck. We can follow it all the way through the process. You know, by controlling the system, we also don't need unnecessary purchases. A lot of times people will buy more than they need to make sure that situations like this don't arise. So there's huge cost savings in that. You know, the other big thing that we find out, in all honesty, is when it comes to trying to locate parts. How many times have you had customers get a crate, put it in a plant, and then, you know, the next day they can't locate it for some reason? So we can track that down anywhere within the plant. And again, that's a pretty big advantage for us. So that's pretty much the advantages of why RTI for us is a very good solution. I get back to the reading gates, and I'm going to jump this slide because this is a little redundant, but I'm going to get into this slide. And the difference with our system is it's on the right-hand side, is we can filter our systems. What happens quite a bit is pallets or boxes are going through a reading gate. If the picture on the right shows another pallet sitting very close to the gate, and in most gates sends out such a strong signal that you'll be able to identify that. So that could cause some grief if we're reading multiple panels and pallets, and that pallet's not going to that customer. We could have confusion. So basically what we can do is we can filter out the pallets, we can filter out the parts, we can filter out just about anything we need to. So the first picture on the left is basically showing how it can be filtered down just to make sure that we're getting the pallets or the boxes that are going through the gate to read. So again, that causes the consistency and the efficiency that we're looking for, that we're not getting multiple reads of false tags or false trips. E-Combine, this is kind of what it looks like. We're actually in the process of integrating a system of our own system. Right now, we're working with most people's shelving systems. We just supply the tags and the RFID readers and things of that nature. But enough of our customers come back and they want to see it truly automated, where they can hook up conveyor to this and we can run with this. So it's something that SICK is right now in the process of doing. Or again, we can customize a solution for you or your customers depending on your requirements. So it's just not limited to this. It's just a matter of, kind of sky's the limit and see what we can do. So just review the E-Combine. Basically the motivation here is efficiency, right? And there's optimization in both, both systems. A lot of, kind of track and trace, air proofing, as we talked about earlier. I'm not going to be redundant and go over some of this, but just making sure that we have the right parts, make sure we have the right container. The RFID is integrated into into your ERP system, into your cloud, the higher level system that you're using. So it's definitely, Industry 4.0 ready. There's a lot of information we can bring, and just a good advantage for us. So I believe this is probably getting down to my last slide, but at the end of the day, it's again, lean manufacturing just in time. That's probably the most important thing for our customers overall, whether it be the supplier, the OEM, or even the end user. So that helps. Again, just the whole efficiency of making sure that we're getting the right parts, the right number of parts, making sure we're controlling the variance of parts, that, we're just delivering what we're supposed to be delivering. We're seeing a lot of requests for the E-Combine, or what they're calling supermarket or e-supermarket systems, which are basically larger scale systems than this. This is, this is just showing one rack. We're being asked to work with a whole, racking system within a whole either warehouse or even a manufacturing process from start to end. So, again, it's becoming a very popular trend. I know that a lot of companies are looking into this. There's not very many people from a competitor standpoint that do this. Again, one advantage SICK has by having the portfolio of products is we can customize a system for you using whether it's vision or barcode, and we do that almost daily. People mix technologies because of the different requirements from their end users. So it gives us the advantage to say, all right, we'll use a barcode reader here, a vision, a machine vision camera here. Oh, and by the way, we'll use an RFID system here. So again, flexibility on SICK's part is a good advantage for us. I know Matt talked about this a little bit, but this is just kind of a high level slide that talks about, we have the sensors, we have the integration products, and we have the software. Again, we're focusing basically on integrating our solutions. Just to be clear, we're not an integrator. We're not trying to go after other people's business as an integrator. We're just integrating our own products, although we can integrate into other people's system as we need to. So that works fine. But SICK has the whole, whole portfolio of, the hardware, the, middleware, and then the software. So we're ready to, take on that challenge. And with that, that's my presentation. I'm going to turn it over to Mr. Jeff Reamer as he talks about some of the trends in the tire industry.
Good morning, ladies and gentlemen. Jeff spoke at pretty good length about kind of generic part flow within the industry. And I'd like to zoom in a little bit on one specific component here. Specifically, it's a component obviously we're all familiar with, tires, but what really are the use cases, for example, for tires? Why are we even having this conversation about RFID? The reality is that right now in the manufacturing process, tires are tracked throughout the entire process using a barcode label. There's a barcode label on every tire, and the reality is that read rates are very high. There's an extensive network of hardware available to read barcodes, omnidirectional, fixed position, handheld. And there's been a number of systems developed by SICK as well as other competitors in the market for reading of finished tires, green tires, bottom reading, consumer labels, and on and on. So why are we even having a conversation about RFID? There are tens of millions of dollars of infrastructure in barcode in the plants now. So what advantages does RFID bring? Why look beyond that? So the first thing to realize is that RFID has overcome all of the technical hurdles to be a viable option for the tire industry. Tires go through a curing process, which is a high temperature process, and the high temperature ratings for the tags are sufficient to withstand that. And there's been extensive lifespan testing completed to make sure that the tags will survive not only the manufacturing process, but as we'll see well beyond that into the use cases that come from the end users of the tires. The processes for affixing those tags into the tires are pretty well established. And UHF technology offers practical read-write ranges for use in the plants. This is not really a new trend. The automotive industry, together with the AIAG, began a process of standardizing RFID tags as early as about 2001, 2002. And so there are now current unified standards that were adopted in 2019 that standardize RFID tags for tires globally. And all of the major players, the Goodyear and the Michelin and the Bridgestone, the Continentals, the Pirellis, and everyone else were part of the groups that participated in the standardization of those tags. So now we're going to end up with tags that everyone will be able to read, and all of the end users beyond the manufacturers will also be able to work with. It's also important to note that the Chinese government is requesting RFID tags in all tires sold in China by 2023. So we'll get into a little bit more about why specifically they're asking for that, but that's a large driving force. Obviously, there's quite a few vehicles and a growing number in China. So that's having significant impact on the market as well. So what does RFID offer us? Why all of this effort and why this growing trend? The ability to write data throughout the life cycle of the tire is obviously an important piece. And it's critical to remember that the life cycle of tire is far beyond the manufacturing as well. It also includes logistics and warehousing. It includes fleet management for the people who operate large fleets of trucks and so forth. There is also a significant piece of this for the consumer market, and the retreading market will be a large factor as well. RFID offers better performance in dirty environments because we don't have to worry about the optical scenarios that we have with reading barcodes. We don't necessarily require line of sight for read or write. And two big ones that we'll drill into a little bit more are that the RFID tag offers counterfeit protection, and it also facilitates recalls. The counterfeit protection, it's kind of strange to think perhaps that a tire could in fact be a counterfeit item, but it's a real thing and actually a growing trend, unfortunately, in the marketplace today. It presents a significant safety concern and obviously undermines the business of the legitimate manufacturers as well. So the use cases for RFID for the manufacturers within their plant, it really begins even before we put a tag in a tire. So there's before implementation, it's read again at the tire building machine. It'll be read again before and after the curing process, then on out throughout finished tire, out through the distribution facility, and we'll see those tags again when they come back to the retread. Before application, before we even put the tag in the tire, we're probably going to read that tag to verify that it's functional and maybe to establish a unique ID number. But we want to verify that before we put it in the tire, not afterwards. At the tire building process, we will also verify that the tag is present and establish a link between the RFID tag and the 1D barcode so that those two are tied together in the MES system. These applications are pretty much serial product. You can mount a standard read-write antenna device nearby and read the tags directly on the drum. As we look beyond that, and we now have a tire which is going to the curing department, it's a little bit more involved application because the tag could be rotated anywhere within 360 degrees. And under those scenarios, we're going to be looking at a little larger system with a multitude of antennas to correctly find and read or write to those tags. Once we get to the final finish department, this is typically where we see manufacturers beginning to write end user data to the RFID tags. So this is data that will be utilized by the people who buy the tires, not necessarily by the manufacturers. And there is a separate storage space on the tag that's reserved specifically for the data that they request. And it's also true that all the manufacturing data of what plant, what time, what date, et cetera, all those types of things will be embedded in the tag as well. Logistics and warehousing will also utilize RFID tags for many of the same reasons. And since tires are often shipped through importers, exporters, wholesalers, and retailers, it also provides an opportunity for fraud detection. So if there are tires entering the supply chain, which are not legitimate tires, those tags can be identified and sorted out. It's important to recognize that the tire is definitely identified as a safety critical component on a vehicle. And due to this, the US government in 1970 created something called the tire identification number. It's a 12-digit code. It's molded into the sidewall of every tire that you manufacture, and it identifies the manufacturer and the plant that it came from, tire size, the specific type of tire that it is, as well as the week and the year of manufacture. This was done to a good extent to facilitate recalls of tires. The problem is that it's a very tedious process for someone in an auto shop to look at the tire identification number on the sidewall, manually write that down, go to a database, look up each of the 4 tires, and decide, is this a tire, for example, that is under recall or not? The practical reality shows us that that's not happening in today's world. The average return rate for defective tires in a recall runs about 30%. It's a highly variable number, and sometimes you'll see it as low as 10%. In other cases, you might see it as high as 60 or 70%, but it's nowhere close to 100, and an average is around 30%. That's because it's a very manual process. The issue that leads to is the fact that there are millions of defective tires on the road. And there are a number of cases where recalls have been issued for known structural defects in tires. Those tires have, for whatever reason, not been pulled off of the road or off of that individual vehicle, and they've ended up in catastrophic failures, resulting in injuries and death for people. That's a nightmare scenario for everyone involved with the supply chain, not to mention the folks who were involved in the crash, right? So the thought is that if we have RFID tags in tires, it can be as simple as using an automated handheld unit to scan those tires. If those tires are subject to recall, they can be identified very quickly and easily. It's better for the consumer. It's better for the manufacturer who gets rid of defective product, and it makes a much better system overall for the industry to work with. There's also an aspect of this industry that most people probably aren't aware of, and that is used tires. The Rubber Manufacturer Association actually estimates about 30 million used tires are resold every year. It's primarily in the commercial vehicle market, right, for truck and bus type tires. But since you have multiple layers in that channel, it's almost impossible for tracking to occur. And the age of the tires is not regulated, nor is there really any way to know without manually looking up the tire identification number. But data has also shown that tires over 6 years start to show a much higher rate of catastrophic failure. There's simply chemical changes and wear in the rubber and the compounds that they simply don't last forever. And so automotive manufacturers, together with tire manufacturers, are working with systems where we can write data to the RFID tags in tires so that we can record things like temperatures, vibration, and pressures so that people working in the used tire market will at least have a little bit of data on the past history of those tires and what they've been subjected to. As it is now, they're pretty much cleaned up, sometimes painted, and it becomes buyer beware. Retreading is kind of the last step of the process. The commercial tires that are in use out there, I'm sure you guys have probably seen retreads that have peeled off and are laying by the roadside or on the highways. It's pretty common in the commercial tire market to retread tires. After fuel, tires is the next most expensive component to operating a fleet of vehicles. So retreading presents a lower cost alternative. When those tires come back into retread, RFID tag allows the automatic identification of exactly what tire it was, what the age of that tire was, and what its usage has been, so that the proper retreading can be done. And it also allows immediate fraud detection when it comes back to folks as well. So an opportunity to pull what could be suspect tires out of the market. So SICK has designed a portfolio product. This is not a one-step process. We are talking about reading and writing RFID tags from the very beginning before they're even placed in a tire all the way on through to complete tires in logistics and beyond. And so we have a scalable approach from serial product, where the manufacturers are ultimately taking responsibility with some support from us, but taking responsibility for the overall performance of the system, up to and including complete turnkey systems where SICK is responsible for the overall performance of the system. At a serial level, integrated read-write a single housing, IP67, strong LED indication, SD memory card for cloning functionality, and the built-in protocols that people are looking for communication. This is a scenario where, again, the manufacturer kind of takes responsibility for the performance of the system. We also sell a little bit higher end system where SICK will take responsibility for the performance with guarantees of read rates, et cetera. We start talking about start-stop functionality and integrated tracking, and a controller that coordinates all of those efforts. Beyond that, at the high end, you take a lot of the components from the last system, add a little bit more flexibility, and provide shielding to the system, and you kind of end up at our pro concept. The shielding is important because as we read-write to any item, we want to make sure that we're reading and writing to the correct item and not perhaps something that's on a conveyor overhead, laying on the floor next to it, or on a next door conveyor. So the shielding allows us to control that if necessary in the environment. So a little look at the RFID in the tire industry and where we see that industry going. And with that, I will turn it over to my colleague, Tom Benucci.
Thanks, Jeff. Get the sharing here. All right, so quick introduction of myself. So I'm Tom Benucci. I'm on our transport logistics team. I'm the sales manager for the team. I've been with SICK for a little over 15 years, working with mobile platforms and mobile vehicles. and I live in Southeast Michigan near Auburn Hills. So the focus of my presentation today is going to be on localization specifically for mobile vehicles. It's taking a second for the slide to advance. So SICK has a wide range of offerings for mobile platforms, and we have something that fits pretty much any of the mobile platforms that are out there today. So anything from the small autonomous mobile robots all the way up to the fully customized AGVs. And we're seeing these autonomous mobile robots becoming more and more popular. These vehicles replace anything from a push cart, sections of conveyors, forklifts, and even floor cleaners within a facility. So as the use cases continue to evolve, SICK's going to be there to provide the right solution for that application. These solutions fall into primarily 3 different categories. So that being navigation and positioning, environmental perception and safety, or your general sensors for collision avoidance and so forth, and then load handling sensors. So Jeff, they talked about some of the different technologies, including RFID, but the focus of my presentation is really going to be on the localization solutions. So for well over 20 years, SICK has provided safety-rated LIDAR sensors for autonomous vehicles, and these provide the critical eyes into the surroundings for these vehicles. So this non-contact safety technology is highly configurable, it's adaptable, and it really helps work within the vehicle surroundings. So on the slide here, you'll notice some colorful shaded areas around the vehicles. And in these 2 pictures, what you're seeing is the warnings and the stop fields. So this is kind of a traditional use of a LIDAR sensor on an AGV, for example. You'll have a field that tells the vehicle to slow down, and then another field that actually tells the vehicle to stop. So if a stationary object or a moving object or a person comes into the path of the vehicle, these sensors allow that vehicle to maintain control and avoid collisions and injuries. And then actually in the right-hand picture there, you'll see a little white box that shows a bunch of green lines. And what that's actually depicting is the raw data that these LIDAR sensors are generating. So the LIDAR sensor is it's scanning the environment, and it provides a bunch of different data points that can be used for the localization. So in addition to the autonomous vehicles, there's a lot of those sensors have become really quite common as the autonomous vehicles have been produced over the last 20 years. So you probably have seen those within facilities. One of the things that's picking up as a trend now is not only do we provide sensor solutions for autonomous vehicles, but we also provide solutions for the manned vehicles. So on this slide here, what we're showing is a LIDAR sensor with a controller that's actually mounted to a manned forklift. And this can really be used in virtually any manned vehicle. But you'd mount a small compact sensor to the vehicle, and then you configure the zone that you want to be alerted within. And what it does is it actually acts as an aid for the driver. So it's like an extra set of eyes for the driver that's looking all the time, whenever the vehicle's in reverse or whatever direction of travel you choose. And if something comes into that field, whether it's a moving object or a stationary object, the sensor system will actually alert the vehicle with both a visual and an audible warning. So before I dive right into the localization solution, I thought it might be interesting to talk a little bit about the basic functionality of a LIDAR sensor. So LIDAR is actually the blending of 2 words. It's light and radar. And LIDAR uses light to illuminate a target. And then like radar, the device actually calculates the amount of time it takes for the light to be sent from the sensor, bounced off an object, and then that's used to calculate the distance. So in the case of a SICK LIDAR sensor, we're using invisible infrared light. So it illuminates the surroundings without actually being detected by humans, so you can't actually see the light. The laser is pointed internally in the sensor onto a spinning mirror, and that spinning mirror actually spreads the light across the entire room. So that's what this picture in the middle here is showing. So it's it's taking a snapshot, and this happens all very quickly. So the spinning mirror, it finishes a cycle as fast as within less than 10 milliseconds, depending on the scanner. So as that light is being cast around the room and the measurements are being taken, you can actually, since we know the position of the mirror, we can actually calculate the distance and the shape of any object within the field of view. So that's what that bottom picture is showing. So you got, square, round, and octagon-shaped objects as examples there. So we've actually been doing, SICK has actually been doing localization for almost 20 years now. We've had solutions starting with our NAV 200. And what that scanner did was it was a dedicated scanner that was mounted, high above the vehicle, above any pedestrian traffic that might occur within the facility. And it required reflectors to be mounted on the walls or posts within the facility. So at the time, this provided a fantastic alternative to more conventional means of navigating a vehicle, such as in-ground wire line guidance or magnetic tape, for example. So it's a much cleaner look. It reduced the maintenance of the vehicle fleet overall, and it provided a lot of path flexibility. So you weren't tied to that specific line that was already in the floor. You actually could navigate using the laser and adapt your path basically at will. So as technology has evolved over time, these scanners have become smaller, they're faster, they're more accurate, more repeatable, and computer technologies have evolved as well. So we're able to actually analyze a whole lot more data much faster than we could previously in the older systems. So fast forward to today, and what we have today is a product that we call the LIDAR lock. And what that is it's a combination of a LIDAR sensor, as I described in the previous slide, and then a controller and software. And what the LOC stands for is it's actually an acronym that's location on contour. So what this system is able to do is it actually analyzes, it takes the measurement data that I mentioned in the previous slide, it pulls all that information in from the sensor, and then it actually creates a map of the environment. So that's what we're seeing here. So all these contours, so these blue dots, this is measurement data from the sensor, and that's actually showing what the walls and doors and so forth within a facility would look like. So that information is captured by our LIDAR lock system, it's analyzed by the software and saved, and that creates a predetermined map. Then that data is then used by an upper level control system that actually creates the path for the vehicle. So the system can really kind of be thought of like a combination of a GPS and autopilot system that you might have, for example, on a plane or a boat. But the difference being that LIDAR works indoors, so you can't, obviously can't use GPS inside a building because you don't have line of sight to the satellites. And then it's also several orders of magnitude more accurate. So we can get down to a very fine accuracy and repeatability with a LIDAR sensor. So the solution, a couple things that are kind of unique about the LIDAR, the SICK LIDAR lock. It's very versatile. So you can use it in any type of mobile platform, as I mentioned earlier. And that's not limited to just automated vehicles. It also would work in a manned vehicle. So you could actually take a small compact sensor, our small controller with the LIDAR lock software on it, and install that on, for example, any manned forklift. It could be a 10-year-old forklift that's roaming around the facility. And instead of having to say radio to the operator to find out where the operator is, or just sort of look out in the building, you could actually send that information from the LIDAR lock software up to an upper level warehouse management system, or even to a cloud. And the data that comes out of the LIDAR lock is actually reduced down to basically three things. It gives you an X and Y position within the facility, and then a rotation angle of the vehicle. So you get the heading of the vehicle as well. So you could quickly monitor an entire fleet of vehicles. You could analyze that data using spaghetti diagrams to figure out maybe where you have high congestion and optimize some routes. And then when it comes to autonomous vehicles, if you had a LIDAR lock system on your autonomous vehicles and also on your manned vehicles, if for some reason there's congestion with manned vehicles, you could actually have the autonomous vehicle automatically reroute and take a different path to avoid that congestion. So here's kind of an overview of the ecosystem of the LIDAR lock. So it starts at the base with the LIDAR sensor, like I described earlier. So you're getting all the data from the LIDAR sensor, and that I should mention that works with any number of different SICK LIDAR sensor solutions. And we can even take in more than one data point. So you could have a scanner, for example, on the front of the vehicle, and then another scanner on the rear of the vehicle. So that data is then fed into one of our CPUs, which is running our AppSpace software. And then within the app space software, we're running our LIDAR lock software. So that's able to analyze all the data coming in from that scanner. Those, it's 200 up to 270 degrees of data at 1/4 degree accuracy every 10 milliseconds. So as you can imagine, it's a ton of data points. So the CPU is analyzing all that data, the software is processing it, and then providing you with just that X, Y, and rotation data out of it. So that can be fed into upper level warehouse management system or some kind of cloud system. So I have a short video here, and there's a little bit of background music in the video, but there's no voiceover. So one of the things we typically like to do with this LiDAR solution is we'll actually bring a compact sensor with our little controller and then a battery pack, and we can come into your facility, we can set the sensor down on something as basic as an office chair, power it up, and then pull it up because it's all wireless Industry 4.0 stuff connected to just a cell phone or a tablet, and we can actually show you the map of the facility. And we just push the chair around your facility. It takes in all the raw data using the LiDAR, and then it quickly analyzes and creates a map. If within a couple of minutes, we can show you the location of that virtual AGV office chair anywhere within the facility, all wirelessly. Since we can't do that today, I thought we'd overviews what that demo looks like. So in this particular example, this is a very small little AMR. It has one of our safety scanners and then that compact controller. We can put a vehicle in any environment. It scans the existing infrastructure, walls and doors and so forth, and it creates all these scanned data points. And another cool thing is our software is all web-based, so you can actually log into it from a web browser. You don't have to install anything. So then what this is showing here is the position of the vehicle. So here's that map of the facility that's created by the LiDAR lock system. And then they can zoom in on where the vehicle actually is. Now they're enabling the system, and so those red dots are the live scans that the vehicle is seeing within the facility. And then what this video is going to show is that one of the main benefits of our solution is that we can operate with, it's called a dynamic environment handling. So we can operate with a much reduced view of the surroundings. So what they're showing here is that a bunch of objects have been placed within the vicinity that weren't there when we created the initial map. So you're seeing that in the upper right-hand corner. There's those 6 boxes that weren't there before. They show up in red. And the vehicle is able to navigate all the way around any of these and still maintain its location. So it's a very, very robust solution. As I mentioned earlier, this is a different vehicle configuration, so it has a different safety scanner in the front and then one of our low-cost TIM sensors in the rear of the vehicle. So we're able to blend the data coming from 2 different LiDAR sensors too. And then what this is demonstrating is we can also take in inputs from the encoders and actually follow vehicles who have almost no view of their surroundings and still get accurate position. And then now we can also add reflectors that don't need to be surveyed in any particular location. They can actually be located randomly. So if you had, like, say, a really, really long corridor or maybe a bunch of shelves that all look the same, you could mount a couple of reflectors and increase the robustness of the system further. So here's another view of what, kind of an overview of what the LiDAR lock software provides. So one of the new functions we've added is we can record the environmental raw data. So what this allows us to do is we can actually, the end user, someone who's building their own AGV or retrofitting an existing vehicle, they could actually do this scan themselves. So in previous versions of the software, we had to actually send out someone from our global service group to do that for you. But now that's something that can be done by the operator. We've also added an integrated data recorder. So it's kind of like a LIDAR DVR, and it works directly from the browser. So you don't need any extra software to enable that function either. Then we can also export a CAD file. So if you want to import that into path planning software, for example, it's an easy file format to work with. So again, some of the benefits of LIDAR lock, excellent performance. So we have very high position accuracy, and we're actually going to be updating the specification to, I believe, plus or minus 10 millimeters for the accuracy. So we've done some further updates with a new version that'll be released here shortly that's even better accuracy than what we're showing on this slide. So cost savings, it's easy to configure. So as I mentioned, it works on a web-based, so it's SOPUS Air is the name of the software. So that's SICK software that's running on our CPU, and you can access it from virtually any web-based browser. And we also have ROS integration. So if anybody's using ROS, which is Robot Operating System, we can connect directly to that for doing the path planning and so forth. And then, as I mentioned, some of the intelligent functions the system can really work well in a highly dynamic environment. So even if you've got pallets and forklifts and a lot of foot traffic and things are constantly moving within the facility, we only need a small amount of that original view of the map to be able to successfully navigate and localize. And then we have also added the reflector support and the odometry support with the encoder inputs. So you can add reflectors to the vicinity if you've got a highly dynamic, like maybe the facility, you got long corridors and lots of racking that all essentially looks the same. You can differentiate that pretty easily by just mounting a couple reflectors randomly within the environment. So one of the things that I'm pretty excited about that we haven't talked about just yet, but it's a new coming feature in end of 2020 or beginning part of 2021 is up on the upper right there, LIDAR lock with a new hybrid feature. So there's a ton of vehicles out in the field today that use that line guidance or the magnetic line guidance that I mentioned earlier in the presentation. And with this new hybrid feature, what we'll be able to do is mount an inexpensive LIDAR sensor or upgrade the safety scanner, for example, on a vehicle and add our CPU and software to it. And you'll be able to convert a vehicle that's running today on a magnetic line to a vehicle that's running just based on LIDAR. And the process for that is you add the hardware, as I mentioned earlier, and then let the vehicle run a couple times through the magnetic path, and the system actually learns what the magnetic sensor is reading and where that is within the environment. And then the system will emulate that magnetic sensor so that you can actually retrofit old fleets with that. So it's a pretty exciting new feature. So we have upgraded our service offering. So as I think we mentioned in some of the earlier presentations, SICK has a global footprint, and we have a very large lifetime services organization. So if a customer would like some help either with doing the mapping or customer training or just getting up to speed faster, those are all services that SICK can offer. So with that, I'd like to thank everyone for your time and open up the presentation for questions.
Perfect, thank you. So we did have a few questions come in, and anyone can really take this. So the first one is, why did SICK get involved in localization?
Tom, you want to take that one?
Sure. So it's sort of I think a pretty natural progression as the sensors and technology evolve. We've been doing sensors for over 70 years, and as in the early days, the sensors required a whole lot of integration on the part of an OEM or a systems integrator to actually get them to a functional state where they could perform within the system. So as our company's grown and we've seen the need in the marketplace grow, we just decided that was a good place to invest some of our R&D, was to actually provide more of a user-friendly solution that can be easily implemented by even an end user. It doesn't require an OEM or an integrator to do it.
Oh, perfect. There's a few more, and I want to find anyone that has questions, feel free to enter them into the Q&A. So the next one is, what industries do you see adapting these localization solutions the earliest?
So I could take that. So obviously with the race to Amazon, the logistics automation world really took on the track and trace, the RFID, the localization of things, with companies like UPS, FedEx, everybody wanting that instant, where's my package, all the way to the end user at home. So that's where we saw the big boom, especially with RFID and localization, track and trace. What we're seeing is the emerging in manufacturing, especially with some of the current environment where everybody's trying to go lights out. We are starting to see a big boom there, and also flexibility by moving to AGVs, AGCs, as Tom brought up, being able to understand where those vehicles are and create a map. You know, right now, 10 years ago, you'd have to create an AGV model where you would create a path, and that would be the path it went. Now with the solutions we have, very flexible to say, what's in my way, let's get out of the way, let's create a new, maybe, one-piece flow. So manufacturing is where we're seeing it, but the early adopters were definitely the logistics automation.
Perfect. Is there any further information available online regarding the hybrid system with magnetic?
Yeah, I'll take that one. We've not yet, so it's an unreleased version of the software. So I would recommend getting a hold of us directly if you're interested in more information about that, because we have not published anything on the website.
Perfect. And then that was from Corey, so you can reach out and we can make sure we get you connected with Tom or someone from SICK.
Sounds great. Thank you.
Yeah. How does the LIDAR IOC system identify the location of the robot in case when the robot loses power and boots back up?
So yeah, that would depend on where it's booted back up in some cases, but it can dead reckon. So that's another, probably another good question. That's something we'd probably want to look at based on the application.
Okay. And I would say the same thing is to that person who asked the question, we can connect you directly. Perfect. Okay. So does SICK act as the systems integrator or work with other systems integrators when implementing these systems?
I'll take that one on. Yeah, we do both. I think I mentioned during my presentation is our first focus is to integrate our products and our systems and our solutions. But that doesn't mean we can't integrate into other people's solutions or machining or tooling as it goes on. So, we're not an integrator just looking for work and trying to be a project manager type scenario. But we can definitely integrate our products, our solutions, and our systems into our products or into other people's tooling as need be.
Okay. All right. It looks like we have one more. So if anybody else has any questions, please add them now. For the moment, the last one is, does SICK have any other solutions for autonomous vehicles like AGVs and AGCs? Yeah,
we do. We have a lot of we have a lot of different solutions for mobile platforms. So the LiDAR lock is a very cool and important part of it, but it's actually kind of a much bigger portfolio. So we have a lot of laser sensors, a lot of photo eyes, a lot of proximity sensors. We can do tilt and yaw on vehicles. We can do pressure sensors, pretty much anything non-contact and even some contact solutions. So we have a lot of safety solutions, a lot of ID solutions, and a lot of detection solutions.
Perfect. So there's, again, more information that someone can definitely learn there.
Absolutely.
So we'll connect them to you as well. Well, perfect. It doesn't look like we have any other questions at the moment. So I want to say thank you guys all for joining, Tom, Jeff, Matt, and Jeff. This is going to be recorded and it'll live on our website. So feel free to share this, watch it again. If you guys have any further questions, you can reach out to me and I can connect you to any of the presenters today. And just a reminder that we do have a tech takeover coming up. It's going to be how to leverage Internet of Things analytics on the path to your transformational journey. And that's going to be by CenturyLink coming up this month. So thank you everyone for joining me this morning, and I hope you guys have a great week.